Welcome to lesson 2.8. We are going to graph quadratics that are in vertex form. Last lesson you learned the basics about quadratics, and now I'm going to show you what they look like when you graph them. We are going to identify the transformations. We are going to identify the vertex, the axis of symmetry, as well as the minimum and maximum. We'll also locate the x-intercepts, which we'll call zeros from now on. Let's compare. These are parent functions. You have worked with absolute value parent functions. You've also worked with linear parent functions. And now we're going to be working with quadratic parent functions. And notice the squared up here. The degree is 2, and that indicates that this is a quadratic. So let's look at some similarities between all these parent functions. First off, if you'll notice, the vertex here on our absolute value function is at 0, 0. The quadratic function also has a vertex here of 0, 0. And if you'll notice that this linear function does go through the point 0, 0. So when we start off, really if we compare the absolute value function to the quadratic function, they look very similar with the exception of the fact that the absolute value function has linear legs. Right? The slope is up 1 over 1, up 1 over 1. Whereas this quadratic does not have linear legs. It does go up 1 over 1 for the first point, but then our next point goes up 1, 2, 3 over 1. Another thing that's similar between these two is that if I were to put a mirror right down here on the y-axis, right down the middle, we could call that the axis of symmetry because the left side is symmetric to the right side. Same thing with this quadratic function over here. The left side and the right side are symmetrical. So the line right down the middle, we will be calling the axis of symmetry also from here on out. Okay, now we will be looking at some key points in our parent function, in our quadratic parent function. So here it is graphed. F of x equals x squared, which is just y equals x squared. Let's identify the vertex. So as we stated before, the vertex is 0, 0, and that is where the lines intersect together, the legs, right here. That is our vertex. So then we have to determine, do we have a minimum or a maximum value? So if I look at this parabola, I'll notice that down here, this is the lowest value that I possibly have. But as the lines continue up, and you know this from your domain and range, they continue up and out forever. So these lines will go up to infinity. So what we really have here is we have a minimum value because this is our minimum, no maximum value. So what I'm going to do is I'm going to circle minimum, and then I'm going to list what my minimum is. So on my parent function, the minimum point is 0, 0. Now let's look at our x-intercepts, which, like I said, we'll call these zeros. So the reason they're called zeros is because if we're looking for the x-intercept, y is always 0 here. So if we plug in a 0 for y and solve for x, that's how you find your x-intercepts. And we've had a little practice finding x and y intercepts, and that's why they're called zeros. So our x-intercept is just right here. We only have 1. And that x-intercept is also 0, 0. Obviously, if this parabola were to move around left or right or go up and down, or flip from being open up to open down, that would change our zeros or our x-intercepts. And we'll look at that when we are looking at transformations. Now let's find the equation of the axis of symmetry. Well, let's draw it in. So the axis of symmetry is right here, this dashed line, right down the middle. And again, think of it as if it were a mirror, and what you have on one side is reflected to the other side. So this dashed line is the axis of symmetry, and we need to figure out what the equation is for that. So if I go anywhere on the x-axis and I make a point and I draw a line through it, that equation will always be x equals whatever it is that I'm going through on the x-axis. In this case, I'm going through the 0, so the equation of the axis of symmetry is going to be x equals 0. And one thing you can take forward is that the equation will always be x equals something because the parabola will always be symmetric with respect to this x-axis. It may move around, but it'll always be x equals will be the axis of symmetry. Let's look at another example of a function that has actually been transformed. We're not going to talk about the transformations quite yet, but what I want to do is look at this parabola and I want to identify some key points in this parabola. So the vertex is always going to be the highest or the lowest point. Here's my vertex at 1, 2. Now, do I have a minimum or do I have a maximum? So if we look at our graph again, this is going to be the highest point in the graph, and then the graph will continue down and out. But that is our highest point in the graph, so that is considered then our maximum. And this is going to be important when we're looking at motion, when we're looking at the way things move. Because of gravity, things go up and they go down, and they don't necessarily go up in a linear constant fashion like an absolute value function, or down in a linear constant fashion. They tend to go up in a curve and down in a curve. So we have a max at the same place as our vertex. And if you aren't already seeing it, there is a pattern. Whatever our vertex is will also be our minimum or our maximum. And that was the same in the previous one. Now let's look at our x-intercepts. So in this case, we actually do have 2 x-intercepts, which will be pretty standard when we're dealing with parabolas. Because of the fact that they form a curve, they will intercept the x-axis usually twice, unless, as we saw in the parent function, the vertex is on the x-axis. So in this case, we have -1, 0, and we also have 3, 0. So remember, these are zeros, and notice that we have zeros in place here for y, and that's why, again, we call these zeros. Now let's find the equation of the axis of symmetry. Well, again, the axis of symmetry is always going to be the line that cuts the parabola into 2 symmetric pieces. So that would be right here along this dashed line that I'm drawing in. So if I want to find the equation of this line, well, again, remember that it's always going to be x equals, and if I go along the x-axis right here to 1 and then draw a line through it, that would be the equation of the axis of symmetry, is just x equals 1. Okay, let's go ahead and look at transformations, and let's compare between our 3 equations that we've looked at so far. So in all these equations, we have an a. So let's look at what a represents for us. And they all will represent the same thing in every equation, and that's the nice thing about transformations, is that they're all very similar. So our a term, remember, is our slope, or our rate of change. Okay, and so we call that a stretch of whatever the amount is, or we call it a shrink. So it's a stretch or a shrink, depending upon what our number is. And if you remember from these 2 functions, it's a stretch if our number is greater than 1, and it's a shrink if our a value is less than 1 but greater than 0. So if we have a fraction, it's a shrink. Okay, we may also have something in front of our a, and we might have a negative sign in front of the a. And if you think about what that does, in our linear equation, it flips it over the y-axis and the x-axis. In the absolute value equation, it flips it over the x-axis. So if you look at these 2 equations, our quadratic and our absolute value, they're virtually identical with the exception of the squared up here. So it will do the same thing. It will reflect the function over the x-axis. So reflect over x. All right, let's move on to our h value. So we have an h value here, we have an h value here. We do not have an h value here with our linear equation. It's too simple to have an h value. So let's remember what that h value is. That h value is now going to be a shift. And we just need to remember, do we shift up, do we shift down, do we shift left, or do we shift right? And if it's in here with the x, like it is with the absolute value, and our new one, the quadratic, then it shifts left and right along the x-axis. So this shifts left and right. Okay, the tricky thing about this is that it always shifts opposite. So for example, if we have x minus 2, we know that's going to shift right to, not left. Okay, and if we had x plus 2, then that would shift left to. And if you remember that from the absolute value equation, it's because in here we're trying to find the x-intercept of the vertex, which means you plug a 0 in here for y, and when you solve, you would have to add the h to the other side. Just like here, you would have to add the 2 to the other side. So in fact, x would equal positive 2, not negative 2. All right, looking at our final transformation, we have a k. And that k in a linear equation is represented by the b. So it's very familiar to you, and that is a shift up or down. So this shifts our function up or down, depending on if it's positive or negative. And if we're shifting up or down, we're dealing with our y-intercept. And y is already on the other side of the equal sign, so y will equal whatever this value is. We don't need to change the sign. So those are our transformations as a refresher. Now let's go ahead and put those to use. Here's an example of an equation that you might get in some of your practice or your assessments. You would get in a quadratic equation. You would be required to list the transformations, the vertex, the minimum, the maximum, the zeros, write the axis of symmetry, the equation for that, as well as to graph it. Looks like a lot, but it's fairly logical and it doesn't take that long. So let's list our transformation first. So all we have here is a 2. So our only transformation is a stretch of 2. Now let's list our vertex. Well, we don't have any transformation in here next to the x, and we don't have any transformation out here. So we know that our vertex is still at 0, 0. It has not changed. If I look at this graph, we have a positive 2. So one other thing that I can write that will help me determine if I have a minimum or maximum is I know that this graph is going to open facing up. So this is going to open up versus down. And you looked at that in your first lesson, your first video, when you had an intro to quadratic equations. So since this is going to open up, it's going to look like this, which means that our vertex is down here, which means that we have a minimum, and our minimum always is the coordinate points of the vertex, so it would be 0, 0. So now let's look at our x-intercepts, and that's easier to do once we graph it, so maybe I'll hold off on that. The equation of the axis of symmetry is always going to be the x value of the vertex, right? Because it's always going to come right through this center. So the equation of the axis of symmetry will be x equals 0. And if I go back to our previous example, the equation of the axis of symmetry was x equals 1. Notice that a 1 is our x value of our vertex, so that makes sense. Same thing with our parent function. It was x equals 0, and 0 is the x coordinate of the vertex. Okay, now let's graph this. So when we graph it, a couple things we can do right off. We can plot the vertex, which is here at 0, 0. And then we really only need 1 or 2 other points on one side, and then we can plot those symmetrically on the other side. So what I'm going to do is I'm going to make a table of values, something that you're all familiar with from earlier when you dealt with linear equations. And I don't need a very big table of values. And my goal is I'm going to pick some x values, and I'm going to always pick x values that are easiest for me and also closest to the vertex, because if you remember, this curves. So while it's coming out, it starts to get steeper and steeper very quickly, and I don't want to choose 10 and have a point that's 1,000. So I'm going to choose a 1, and I'm going to choose a 2, because those are right next to my vertex in the positive quadrant, which is easier for me to work with then the negative ones. So if I take a 1 and I plug this in, remember your order of operations. You have 1 squared, which is 1, and 1 times 2 is 2. Now I'm going to plug in a 2. 2 squared is 4, and 4 times 2 is 8. And just so that you can see that there is no linear pattern, let's try a 3 as well. So 3 squared is 9, and 9 times 2 is 18. Remember that when we had linear functions, this pattern had to be constant. But now if you look at it, this pattern is not constant. We go up by 6 here, we go up by 10 here, we're going to go up by an even bigger number here. And that's why it's important to choose x values that are very close to your vertex because of how quickly this will grow. So let's go ahead and plot these numbers. So we have a 1 and a 2 here. We have a 2 and an 8 here. And notice I won't be able to plot this point because it's way off the graph. So what I'm going to do then is I'm going to draw in my axis of symmetry. So let's go ahead and draw that in. I'll just put a dashed line right down here. And that way I can plot symmetric points to the ones that I've already plotted, which will make it easy for me to graph. So I have this point which is 1 away from my axis of symmetry, so I'll plot the other one also 1 away. This one is 2 away, so I'll plot this one 2 away. And now I'm ready to connect my points. And notice that I'm not using my line tool because this is not a straight line, right? This is a curve, so this is no longer a linear pattern. This is a nonlinear function. Now I'm ready to figure out my zeros. Well, the graph intersects the x-axis only once at the vertex, so that's 0, 0. And now I've done everything. I've listed my transformations, my vertex. It has a minimum value of 0, 0. I've listed my zeros. I've drawn in my axis of symmetry as well as written the equation, and I have graphed it. Let's try a few more examples. So we'll move a little quicker now. We'll go ahead and list the transformations first. So the first transformation we have is we have a reflection, and I always go from left to right. It's just easier. So I have a reflection over x, the x-axis. My second transformation is the 1/2, and since it's less than 1, I know I'm going to have a shrink of 1/2. And then as I move to the right, I have this 4 on the end, so that will be a shift up of 4. Okay, finding my vertex is going to be the same as I do in the absolute value equations. I have no shift left or right, so my x value is still at 0. I did shift up 4, so my y value is now 4. I'm going to go ahead and plot that on my graph since I know it. My vertex is going to be at 0, 4. One other thing that I notice about this that I'm going to write down is that this graph is going to, because it's negative, it's going to open down. Okay, so that means my graph, my parabola will look like this, which gives me a maximum value and not a minimum value. And remember that my minimum or maximum is always going to be my vertex, so that's going to be at 0, 4. I don't know what my x-intercepts are, I'm going to wait on that, but I do know the equation of the axis of symmetry. That's going to be x equals whatever my vertex is, which is 0. And then I can draw that in with a dashed line if I like, which will help graphing purposes. So here is my axis of symmetry, right down the middle. Okay, now let's create a table of values so that I can graph this function. And we'll do that right here. And I think I'll use a black marker. So, again, it's going to be very important which coordinates I pick for my x. I don't want to pick 6, I don't want to pick 10 because those are very far away. So it looks like, again, maybe I'll go ahead and try 1 and 2. And then when I look at this, I think, 1 squared is 1. 1 times negative 1/2 is negative 1/2, and then I have to add a negative 1/2 to 4, which can be done, but I think I'd rather have it come out even. So I'm going to use 2, because 2 squared is 4. 4 times negative 1/2 is negative 4/2, which is negative 2, and negative 2 plus 4 is just 2. The next number I'm going to use is 4, because 4 is divisible by 2, so I know that will come out even. 4 squared will give me 16. 16 times negative 1/2 gives me negative 8, and negative 8 plus 4 would give me a negative, will give me a negative 4. Okay, so let's plot these points. My first point will be at 2, 2 right here, and my second point will be at 4, negative 4. Now I'll go ahead and plot the symmetric points. So I have 2 this way, so I'm going 2 this way. Here I have 1, 2, 3, 4, so 1, 2, 3, 4 away from my line of symmetry would be here. And now I am ready to draw in my curve. So not as easy as it looks because you are curving, which actually let's try that again. One more time. Okay. And on my last one, something like that. Okay, so looking at the graph, we can find our x-intercepts. And it looks like it's at 1, 2, 3 here, but then it's a little bit over 3 here. So it's approximately according to the graph, and I'm just going to put approximate because it's not really 3, I know, but it's approximately negative 3, 0, and positive 3, 0. So again, it's approximate. It's not an exact science, and that comes with trying to draw this in. In a later lesson, we'll actually learn how to find the zeros. We'll practice it, and then you can find the exact value for the zeros. All right, let's try another example or two. In this one, we have some transformations. We have a -1 here, so we know that we are going to, hopefully you are saying shift right and not left. So we have a shift right of 1. We also have a -6 on the end, which is a shift down of 6. And if you would like to try this on your own, pause the video and go ahead and see if you can graph it and identify the key points, and then come back in and see if you got it right. Our vertex, well, we have a shift right 1, so we have a 1 here, opposite sign, and we have a shift down, so our vertex is at 1, -6. Which I will go ahead and graph since I'm thinking about it. I also know that since the a value is positive, I know this function is going to open up. Okay, so it's going to look like this, which tells me then here that I have a minimum value, not a maximum. And my minimum will always be my vertex. So that is 1, -6. I'm going to wait on my x-intercepts, but I can do the equation of the axis of symmetry. That will always be x equals whatever my vertex value is, which is 1. Okay, so I'm going to go ahead and start with drawing in the equation for the axis of symmetry right here at 1. And it should always go through that vertex, and that's how you know you've done it correctly. And now I'm going to make some key points so that I can graph this. Okay. Here is my vertex, so maybe I would choose 2 and 3. I wouldn't want to choose 2 and 0 or 3 and -1 because I can find the symmetric points easily. So I could choose 2 and 3, or I could choose 0 and -1. And actually, you know, I think I'm going to go ahead and choose the 0 because I know it's easy to solve equations when you have one of the coordinate points be 0. So that means I'll go ahead and choose the -1. Actually, yep, let's do that. -1. So I'll choose 0 and -1. So I plug in a 0 here. I end up with -1, and -1 squared is +1. 1 minus 6 is -5. If I choose -1, then I have -1 minus 1. Remember your order of operations. That leaves you with -2, and -2 squared is 4. 4 minus 6 is -2. So plotting those points, I get 0, -5, and I get -1, -2. I'm going to go ahead and plot the symmetric points right here and right here. And now I'm good to draw in my curve as best that I can. Again, not so easy when it's a curve, but that's pretty close. So I will now find my zeros or my x-intercepts, and it looks like it would be here and here. And they should be symmetric distances away from your axis of line of symmetry. And it looks like I'm pretty close. So I'm going to call this one 3.5, and I'll call this one -1.5. So we have a -1.5, and we have a 3.5. And again, these are just approximations. Okay. All right. And now we have listed transformations. We have found our vertex, our minimum maximum values are 0. We have drawn in our axis of symmetry as well as written the equation for it, and we have graphed this. Let's go ahead and do another example. And if you feel like you're getting this, you can skip the other examples. I just want to make sure that you have plenty of examples to come back and reference when you are doing the practice problems. So let's go ahead and look at this one. In this situation, this negative here, this is a reflection, and right away it should alert you to the fact that this graph is going to open down. So we have a reflection. The +2 means we shift left 2. And the +4 on the end means we shift up 4. Okay? And let's go ahead and write on here that we know that the graph opens down. So I'm just going to draw that in there, which means that we will have a maximum value. This is the highest point in the equation. It's our maximum. So our vertex is going to be a -2, 4, because it's the opposite of in here, plus the 4. And we'll graph that on our graph. So we have -2, 4. We know it's going to open down. Let's go ahead and draw in our axis of symmetry, because I know that it's going to come right here through our vertex. And then let's write the equation of the axis of symmetry. We know that's going to be x is equal to -2. Our minimum and maximum will always be our vertex, but now we've identified that we have a maximum. And we'll wait on the zeros until after we have graphed it. So here's our table. And x-coordinates. So again, maybe I'd like to have 0. So I'm going to go ahead with a -1 and a 0. So I'm going to choose -1, 0. -1 plus 2 is 1. 1 squared is 1. Times the negative becomes -1. And -1 plus 4 is 3. 0 plus 2 is just 2. 2 squared is 4. And 4 times a negative is a -4. -4 plus 4 gives me 0. So I know that I have a point here on the x-axis at 0, 0, which means that I also have a point here at 0, -4, and now I know what my x-intercepts are. Anytime I have a y value when x is, or anytime I have a x value when y is 0, then I know what my x-intercepts are. So this one is a little bit easier to identify that we have 0, 0, and then the symmetric point here is -4, 0. Okay, so let's graph the -1, 3, which is here, and its symmetric point, which is here. So it makes it a little bit easier to graph when I have some points that can guide me through my x-intercepts or my zeros. All right, and that's that example. I have one more left if you're interested. Or if you'd like to go ahead and try this first and then play the tape back and see if you got it correct. So on this one, we have a 2, which is a stretch of 2. We have a -5 in here, so we know we're going to shift the opposite way. So we're going to shift right 5. And we have a -8 on the end, which means we shift down 8. Okay, so for our vertex, we have shifted right for the x part, and we have shifted down for the y part. And we know then that our vertex is going to be a +5 and a -8. I can also go ahead and write in my axis of symmetry. It's going to always be the x-coordinate, so x will always equal 5. I know the value of the minimum or maximum. It's 5, -8, but I need to figure out, again, if my graph is going to open up or down. Since 2 is positive, I know that my graph will open up, and this point right here will be my minimum, so I know I have a minimum. Now let's find some key points that we can graph, and we will then try to identify approximately what our zeros are. So let's see. Let's go ahead and put in our vertex. So we have 5, -8 down here. So I am going to want to choose x values that are near my vertex. So I'm going to go lower, since maybe those will be easier. So I'm going to choose 4 and 3. So we'll write the 3 here. And we have 4 here. Plugging in a 3, 3 minus 5 is -2. -2 squared is 4. 4 times 2 is 8, and 8 minus 8 is 0. So right there, I have a 0, right? I have an x-intercept because y is 0. Now let's go ahead and plug in 4. 4 minus 5 is -1. -1 squared is +1. 2 times 1 is 2, and 2 minus 8 is -6. Okay, so here we go. 3, 0, and 4, -6. Now I want to plot my symmetric points, so what I'm going to do, like I did on all the other ones, is go ahead and draw in my line of axis of symmetry here. That way it'll be easier to plot those symmetric points. So I can see this is 1 away, so I'm going to go over here, and 2 away would be over here. And now I can draw my line and connect it on the left side as well. And I can clearly see here that I know what my x-intercepts are. They are going to be, first off, we have the 3, 0 that we found in our table. And then plotting our symmetric one, we have 7, 0 here. Came out very nice. And that concludes our lesson for today. Those are all of our examples. So I gave you some extra examples that you may need to go through right in your notes in order to help you. Okay, but if you think about what you learned today, you can now identify transformations of a quadratic function when it's in a vertex form. That's what we call it because you can pick out the vertex. You can find the vertex, the axis of symmetry, as well as the minimum and maximum. And you are also able to roughly locate the zeros or the x-intercepts based on the graph.